Hello mathematicians, hope in this video and getting a little bit of practice you can say I can solve quadratic equations by taking square roots. We're going to look at a few different examples in this video of varying difficulty. Hopefully they are easiest to hardest. Alright, let's look at our first example here. So we're given 3x squared plus 4 equals 31 and we are wanting to solve for x in this problem right here. And we're going to do that by using our inverse order of operations. So first of all, we need to get rid of this plus 4. So let's subtract 4 from both sides. And that would give us 3x squared equals 31 minus 4 is 27. And now I'm going to divide by 3 to get our x squared by itself. And that would give us x squared equals 9. 27 divided by 3 is 9. And now to solve for x, we're going to take the square root of x squared and the square root of 9. That is going to give us x equals, and it's going to give us both the positive and the minus of 3, both the positive and the negative 3. So x is equal to plus or minus 3. Because let's think if we were to plug our positive 3 right here, would you get 3 squared would be 9 times 3, 27, plus 4 would be 31. Or if we substitute negative 3 in, go negative 3 squared, that'd be negative 3 times negative 3. Negative times negative would be a positive still, so that'd be 9 times 3 is 27 plus 4 equals 31. So x is equal to plus or minus or positive and negative 3. So that is our first example. Let's look at another one here. So we're given negative 2x squared plus 17 equals negative 21. And again, we're going to solve for x. So we're going to subtract 17 right away, which will give us negative 2x squared equals negative 38. And now we're going to divide by negative 2 and divide by negative 2, which will give us x squared equals 19. So we'd get, and now we'd have to take the square root of both sides over here. And square root of 19, that's an irrational number, so we'll just keep it under the radical symbol. So we give us x is equal to plus or minus the square root of 19. And that would be our final answer right there. Let's look at one final example. So we're given 5 times the quantity x plus 5 squared minus 33 equals 2 rather. And we're going to solve for x again, and we're going to add 33 to both sides. 2 plus 33 gives us 35. On the left side of the equation, we get 5 times the quantity of x plus 5 squared. And now we have to think of everything in this parenthesis as one quantity. So if we wanted to, we could distribute this 5 and then solve it like a two-step equation, or we can just divide this whole left side by 5, which undoes that multiplication. And then we could also divide this right side by 5 as well. So that would give us x plus 5, that whole quantity squared, equals 7. 35 divided by 5 is 7. And now, because this square is on the outside of the parentheses, we have to take the square root of this entire left side, and that gets rid of the square right there. So that gives us x plus 5, that value doesn't change, equals plus or minus the square root of 7. And that's an irrational number, so we'll keep it in radical form. So now this written out, this is x plus 5 equals square root of 7, the positive, or x plus 5 equals negative square root of 7. So now if we were to solve for x on both of these individually, well, we'd subtract 5, and we'd subtract 5. And because this one's a positive, we'd get x is equal to negative 5 plus the square root of 7, or, and we'd subtract 5, and subtract 5, or x is equal to negative 5 minus the square root of 7. And that would be our answer down here. So the final answer would be x is equal to negative 5 plus the square root of 7, or x is equal to negative 5 minus the square root of 7. So that is it for a video. Hope after watching this and getting in a little bit of practice, you can say, I can solve quadratic equations by taking square roots.